tester. Would that be a good way of saying it? So because it's a really complicated system, and because it's you really want to make sure it works, there was a whole team devoted to making sure that that actually happened. So I'm really pleased to have Christoph here. It's really great. It's an honor to have him here. Kind of a high-level overview. Christoph, would you mind giving us your take on what Ethereum is and where did it all come from and where do you kind of think it's headed in the future?
Sure. Thank you very much for that very kind introduction, Ken. Before we go through the things I've prepared, so Ethereum, some call it the world computer. It's a nice name to understand, like it's one computer we all have access to, and we all have the same rights to do things. It's an easy description to think about it. And if you think about the development of computer science, first you had single personal computers, to not go too far in the back history. Now we're all looking at cloud computing and cloud storage, where we just say one company does it for it. Now we just say all the computers are one computer, and we're all working together, and that's basically one idea behind Ethereum. Other descriptions, so more for blockchain in general, my favorite description of blockchain is a distributed permission ledger. And currency is one application of it, but if you think about distributed permission ledger, meaning, first of all, yes, it's distributed to many nodes. So currently Ethereum, for example, has about 6,500 full nodes running. But permission ledger, I think, fits it in the best way, because you can program who has the permission to do what. And that's what makes it different from all the other databases. Otherwise, you could say having a SQL database gives you just data and access to data. You can also a little bit program who can access what, who can change what. But on a blockchain, you can program all kind of permissions, accessibility, who owns something like a token, which can stand for almost anything. For data, permission to open something, permission to read something, permission to own something. Think about smart property. So all kind of permissions can now be programmed in something we call smart contracts. Who has the right to do what at which time? And that's what we're using for this DEO, that's what we're using for Slock.it. And you will see a lot of applications built on top of Ethereum where some permissions are managed.
Yeah? Permission to read. Is it a figure of speech or?
The permission to read is maybe a bit too far-fetched for now, but will be, like you're looking at something called ZK knocks or zero knowledge proof. With this you can program something like this, like having private data on the blockchain. That you can program who's able to decrypt it. But yes, for the current version, I don't think about it as a very powerful computer. Because people also think it's like a lot of nodes means a lot of power. Actually, it's quite the opposite. And if you think about the computing power of Ethereum, someone compared it about to a Nokia smartphone about 1999. So this is the computing power of this world computer. It's almost nothing. So you cannot run powerful applications on top of it, but they run super secure. So it's just for a code snippet, running a little bit of logic, and not for running large applications. If you want to run large applications, then you have to use different systems aside of it. Actually, I have a lot of different slides prepared. Maybe just, if you want to go more about decentralized applications, let's see where's my, I can show you one slide which fits very well. Maybe we can, yeah. So I have, when it comes to slides, I've prepared, well, I've always prepared, we're having slides about Ethereum, slides about Slock.it, and slides about the DEO. So actually it's up to you what you want to talk about today. So maybe I just show some small introduction to Ethereum, which I like. So this is a slide about how a decentralized application could look like. I hope you can all see this. You have the internet, of course, as a basic layer. Then you have those clients, hardware clients, meaning, for example, my laptop running a client connected to the internet. They go this way here. So here comes the technology Ethereum is developing. Actually, this is 3 parts, and only one of them is fully developed. The other one are still in progress. something called the EVM, the Ethereum Virtual Machine. This is what is running on the blockchain. This is what's running those smart contracts, this permission ledger. Then you have something called Whisper, which is a messaging system. So the easiest explanation would be something like, maybe do you use WhatsApp here in the US? Something like just a messaging system without a centralized authority. And then we have something like Swarm or IPFS and other systems where we have decentralized file storage. So when you write a decentralized application, then you're using different decentralized technologies. And today we're only speaking actually about one single part of it, which is the blockchain, the Ethereum virtual machine for the smart contracts. But a complete application needs more. It needs messaging systems, storage, and all of this. And all of those things are provided. And on top of this, now you can build decentralized application. And this is one sketch how this could look like. If you think about one circle being one participant in the application, he's connected to all the other ones through the blockchain here in the middle in blue. For the most basic stuff, you don't do it like a couple of transactions per minute at most. But that's actually already a lot. Maybe a couple of transactions per day or per week. But the messages could go all the way through all the time using Whisper and also using Swarm for some data. But the interface for an end user will be exactly the same. So if you're using a decentralized application, you may not even notice. Because you see a web page written in JavaScript and HTML, you don't see any difference. It's just for the developer which technologies he uses in the background. And I liked also one description of Gavin Wood, the CTO of Ethereum. He said, Ethereum is a zero-cost infrastructure. Meaning you can build applications without paying for servers, basically deploying them and run away. You don't care about them anymore. They will run forever if you use the right technologies behind it. So I think this is maybe enough for Ethereum. I don't think we don't need to go into the technical details today, right? This is not the topic. So then let's stop this presentation. Okay, are there any questions about Ethereum you want to ask me? Because maybe what I'm bringing here today is also a deep knowledge of the protocol. Because what I've worked on most of the time is actually together with Jeffrey Wilke, Gavin Wood, and Vitalik Buterin on the protocol part of it, and writing tests for the protocol, so that writing the client needs to pass the test to see that they all have the same result. So right now we have a client actually in Ruby, JavaScript, Java, Haskell, Go, C++, Python, Rust, actually. So there are a lot of different clients, and they are all using the same tests to see that they're doing the right thing, that they keep true to the protocol. That's what my tests are for, basically. So that's why I think I know the protocol in depth. So if you have any questions to the protocol, we can cover them now before we go to my current project.
JavaScript client running on top of what architecture? Because I don't think it can run inside the browser, right?
It should, but it's not, as far as maybe here Martin Preis is working on this, he may correct me on this, but it's more very modular client, having libraries about how to create transaction, Ethereum virtual machine library. So I would not use it as my client because it's not very performant, but I actually use them for our app for creating signed transaction, because I can just use it in the web app. So we are using parts of it actually as Slock.it, but just as a library basically. But he has implemented the complete Ethereum virtual machine and runs all the tests.
Thank you.
Yeah.
So with the price of Ether on the rise over the last couple of months, is there a lot of competition around proof of work mining recently on Ethereum?
I mean competition among the miners, you mean?
Yes.
Or?
Yeah, or just
difficult
mining for the currency aspect,
Yes.
like miners do. So that's
It's actually they are only incentivized because of this. They're getting
right.
They could also just from this philosophy point of view, like supporting
but
network,
the incentives are stronger now than they were
Yes.
a couple months ago.
which just means you will have more miners, and then
Yeah.
this will settle. Like you will always have an equilibrium because of the price. You can actually calculate how much this would mean in electricity power, and calculate how many miners you will have. Like if it's lower than this, then there are people incentivized to turn on more miners until you have again this level reached where they don't make about that much money as they put in hardware and electricity.
Has Ethereum proof of work moved from GPUs to RISCs or ASICs? ASICs.
I don't think there's any risk. Like when we developed the algorithm called EatHash, the focus was on being GPU friendly and not allowing any ASIC to run this algorithm. So the basic thing is what we did. This was done by Tim Hash. Tim Hash. Tim was his first name. I don't know about the second name Hash. It was something similar. But what we did is the input and output from the memory. This is the bottleneck, not the computing power. So meaning, so inside the GPU you have memory, like RAM, and there's reading and writing to it all the time. And this is the bottleneck. And there's always no things out there which are better than GPUs in reading data.
And that was by design, so
yeah,
that
by
it would be a
design.
bottleneck.
So meaning
Okay.
ASICs, they will not be better than GPUs.
But this is all temporary.
Even though they
I
make
know,
the
yeah,
calculation
proof of stake is
better. Like,
ultimately-
there is the bottleneck is not the computational power. And so ASICs will not gain over it.
Thank you. Okay.
The bottleneck, I mean, you could make a very specific chip for it still, but the cost for development are pretty high, and then you may gain only a little bit. And if you see how effective the GPUs are of mass production, so you would need to be better than them. And I think it's very unlikely, especially since we say we will shift to proof of stake.
Exactly.
And
This is what will prevent any
Yes,
investment into ASIC.
since they know in about maybe 1 year we will shift to proof of stake, it's not forced to invest in the development of ASICs. So I don't think we will see any ASICs in the next couple of years for this. Yeah.
Does your test suite have to be changed a lot to test the same conditions for a proof of stake protocol? Or is it like sufficiently general to test
So it
it?
depends on what kind of test. So there are, right now my test suite has 4, maybe you could say 5 types of tests.
Okay.
The first are the EVM tests. So they may change slightly. Then I have state tests, which are actually very similar, but it's more about when the complete state change or transaction. Like when a transaction comes in, it changes the state. Then most of my tests are state tests, like how this looks like in detail. This should not change too much. For the blockchain tests, which are the next level, and there could be some changes. I expect there will be some protocol changes for this. Usually, also what I'm still doing at Ethereum right now, I'm not very active because we don't have protocol changes. The past, I only have been active when we had protocol changes, and in the first 1.5 years, we had them weekly. So meaning, like I have to change all my tests over again because we changed the protocol. And so I just were writing more and more tests, and all the time we changed the protocol, I changed my tests. And now we had the last work I did was for Homestead, where we changed the protocol. I worked about 1 month for all the Homestead tests, for all the changes we did made there. So now I'm working for Slock.it, but when we have Serenity, I think I will be again asked for writing the tests. So I'm only working there as a freelancer, as a contractor, not as an employee of the foundation.
You said that there were 5 types of tests, and then you named 3. What are the
Oh,
others?
so there are VM tests, state tests, blockchain tests, transaction tests. And then I call it like basic tests, so we test some cryptography stuff, we test some difficulty algorithms, so some small stuff. But that's about the test we have.
Thank you.
Yeah.
Is there anything that could derail the path of the Casper that's putting out? So what is the major hurdle that that's needed to pass in order for Casper to come out, which is the proof of stake?
So Vitalik has written the proof of concept number 2 in Python. So right now, as far as I know, only Python has actually implemented it, and they are playing around and testing it actually there. So I think it's a big change. So they want to make sure that, for example, most importantly, the game trading, the part of it, is perfect. So they are testing it, but I think they are pretty far. I think when Vitalik and Flat consider it as done, then the next part will be all the other clients need to implement it, and I need to write tests for it. And then let's say this takes maybe a couple of months, and then a rollout could be considered. But actually, the proof of stake algorithm, I think, is theoretically almost done as far as I know. But I'm not working on this part currently. So I will be asked maybe to write tests when they say it's done, but only Flat somewhere together with Vitalik between, I'm just working on it. Actually, Vitalik is already working for next part already, so he's thinking far ahead, but it's like sharding, things like he's working on to resolve the scalability issues, but this is more far in the future.
Okay.
Yeah.
Speaking of scalability issues, Do you have a sense about where the proof of stake is at in the idea of the sharding concept?
So sharding is not part of proof of stake. That's completely different.
Okay.
But proof of stake, in my opinion, roughly give us 1 order of magnitude more transactions per second. So it's already a huge step, but it's still low compared to what we want to reach. It's like still far away from being like 1,000 of transactions per second. Like sharding is the full scalability solution where there is no real limit in the sense of and only like more nodes in the network give you more transactions per second. Right now, and the same will be true proof of stake. Like double the number of nodes in the network and don't double the number of transactions per second. Actually, it's the same. Actually, even worse because they have network delay. So, like right now, we have every node processing every transaction. The same will be true proof of stake.
Yeah.
And only sharding can solve the real scalability issues.
If you adopt the sharding and you have shard IDs for one group has a shard ID and you want to talk to another shard ID, is that going to break some of the contracts that are already out on the network? Will some contracts perceivably not be able to?
I hope not in a sense. I don't think we will release anything which is not backwards compatible.
Okay.
The question is only how we are doing it exactly. For future contracts, it always means like if you are making transaction from one shard to another, you would have something like race conditions.
Yep.
And this means also the EVM needs to change. So there are a lot of things will change in the future. I will need to see how Vitalik comes up with a good backwards compatibility solution. So maybe there will be something like 2 EVMs actually,
Okay.
like when we're running old contracts in the old EVM, and he's actually looking at that assembly and other solutions for new EVM.
Okay.
So completely open what's happening there. So it's still completely research under development.
Yeah.
It's not actually what I'm working on right now, so therefore I cannot say
That's
exactly
fair.
what Vitalik has in his mind. Actually.
Yeah.
That's good. Yeah.
So Christoph, could you tell us what you're working on now and give us an overview of Slock.it?
So, who of you have seen my DEF CON 1 presentation? So I think this is enough to not repeat it. So I'll just say it shortly. So basically, Slock.it is trying to connect blockchain to Internet of Things, making it possible for devices to receive payments and send payments. And one example I brought with me is, sorry it's not working because I just received it, but we are working there together with them. This is a padlock, a digital padlock by a company called Fast Designs. It's called Noki. They gave us a developer version for it, so we can put our software inside there, and so we will make it possible for someone to pay to open this lock. And now you could have behind it, let's say, a bike, some tools, big tools, and people can pay to rent them out. They also do bike locks, and they have not released them yet, but we also will be able to open bike locks. DEF CON 1 have showed the door lock, which you open by paying money. We are working together with a large electric company called RWE, where we do car charging stations, so that basically the car can pay for its electricity. And it could even be charged in front of a red traffic light via induction. So they are working on this, that when you have an electric car, you're waiting on a red traffic light, your car gets charged. And for this, the car needs to pay, because you can swipe a card, you can do nothing. So the car needs the ability to pay. And therefore, Ethereum is perfect, because you can make a smart contract, paying a deposit, getting charged, then get the rest of your deposit back after the charging process. And this actually gives the possibility for a global charging system, because everyone can just connect to it without changing anything. Because if the smart contract is out there, like the smart contract from this electric company, everyone can just connect to it. Another thing I like to actually call Ethereum is the Ethereum blockchain is like one big open API. As a developer, you know an API is like an interface you can interact with other applications. And for a blockchain, every application on there it has an open API. Anyone can connect to it. So this is all when I talk about logs, someone did actually make a smart contract to check the weather when the weather was bad, closing his window, using the same smart contract from us as a log. So just a completely different application, but since the API
you have to pay yourself when the weather is bad.
Well, if you're the owner, you get the money yourself back, so then it doesn't matter.
But you pay the transaction.
You pay the transaction.
Someone is way too excited about it too.
But about transaction fees, also if I speak about the logs, and that's actually a nice example. We don't do a transaction for any time you open and close it, because this would be too much transaction fees. So actually on the blockchain, as I said, a permission ledger, we only pay to get permission to open the lock. And after this, you're using Whisper, you send a signed message to open and close. Because it just looks on the blockchain, you are the owner, and then you can open and close as much as you want to. So basically you're only paying for permission to open and close. This you only need to do once. And then you are the owner, and then you can do as often as you want to.
Does Whisper already exist?
Only as a working prototype, so it's working on a sheet. Let's say it like this.
Is it the same account as for Ethereum and for Whisper, private address?
No, this is actually a problem. So there actually are different private and public keys from the Ethereum address to Whisper address. So basically you need to, but we can still solve this. Basically when you buy permission, you need to also say what is your Whisper public key, and then it's stored, and then when you with Whisper send a signed message, you can check, and if it's correct, and open for you.
Can I perhaps pass the lock around so we can touch it?
Sure. Yes. So what was the last point I was discussing? Yes, the smart Slock.it. So basically connecting all the Internet of Things devices to the blockchain, so they have the ability not only to receive and send payment, but also to use it as a permission ledger who's able to use them. Like you could also say, it has nothing to do with payment, I just want in my company to see who's able to open this door and do something in this room. Or even it could be a safe, and only like 5 out of 10 people together can open this. Like you can have a multi-sig behind everything, but just connect those things that they can listen to the Ethereum blockchain to know if they should, what they should do.
Do you have a solution for block confirmation times?
The 70 seconds, or right now 15 seconds actually. I think it's not too bad if you think about buying permission. If you open it, it goes directly with a Whisper message.
So you interact with one confirmation?
Actually, this depends on the owner of this lock. He can set this number. Let's take, for example, the door lock. It's like when I want to buy the permission, it's like renting this apartment. Usually it takes much longer than 15 seconds in the real world. So it means you have like 1 or 2 or 3 confirmations to get the permission that this apartment is yours now. And then when you're in front of the door, it's just a Whisper message. It goes immediately with Bluetooth. Meaning there's no connection, there's no transaction on the blockchain, no confirmation. It opens up immediately since you are the owner of it. Only like becoming the owner and then returning the apartment, this is a transaction. But everything else is just a message.
But when you want to open and lock it, so you have to interact with the Ethereum network, right?
Yes.
But it's not very powerful in terms of executing instructions. So assume that everybody is gonna unlock their phones, and then they will call into Ethereum network. Will it support that?
The code, maybe I should show it a small contract. There's only 10 or 20 lines of code which get executed.
Yeah, but 1 billion of people will
Yes, that's
ping
a
into the-
scalability problem. And I mean, right now, that's actually a nice sweet spot we are in right now. I think the scalability issue will be solved in 2 or 3 years. But if we hit the scalability issue because of Slock.it, then we're already very, very successful.
Yeah.
So that's the nice thing is we can actually go and do it now because we don't have this problem for the next couple of years. Only if you become as big as Airbnb and Uber, then we run into this problem.
But sorry to interrupt you.
Yeah, but the big companies, they cannot do it. Like look at IBM and Samsung, they cannot say all our fridges and all our devices we connect them to Ethereum because they are too many. And that's why the startups now have an advantage of they can use it because they don't have scalability issues, but the big companies, they cannot use it because of the same thing. So
But perhaps if a big company like Apple, which produces popular devices, you just look at that and say, there is obviously scalability issues if all our iPhones start calling in, and they will just not adopt it, right? And they'll come up with something else. So the problem is that it seems like the script will execute on every node, right? So it's kind of bound by the capacity of the network. So you have to make the computers faster to make it work faster, right? It doesn't matter how many nodes you have.
Yes.
Because it will be essentially bottleneck will be the speed of the individual node.
Hold on, isn't there a possibility to not have to go through the blockchain once you've done the initial?
Yes, that's what I mean. You only pay for the renting process once, so it's
Then
not
it's just
that
Whisper.
many transactions
And
actually.
then,
It's
and then
just Whisper.
doesn't have to
It's
be
just-
over the blockchain.
That's just over TCP, right?
But
Yeah,
it does
Whisper is
call
a
into
direct
the
peer-to-peer
network,
message.
right?
Yeah, it's just over TCP.
You
It
exchange
doesn't
keys
talk.
as part of the ownership contract. You exchange keys. I am now the owner of that lock. For me to unlock the lock, I don't have to go through the blockchain.
So you don't need to call into Ethereum
You
network.
don't.
No.
Not if you open the lock, no.
Ah,
If
so
you're
opening and closing.
Reading is free. Like reading from the blockchain is free. It's not a transaction and doesn't, like there is no scalability issue with reading from the blockchain. Only writing to it is limited. So
let me sum it up. The real limit on the power of the node is whether it can internally validate the blockchain fast enough. So only this.
But
And currently we have the block rate is 1 in 13 seconds, which means the real limit of computational power is the node has to be able, the Ethereum computer has to be able to calculate the hash every 13 seconds.
yeah,
Right?
but it's like nothing. I mean,
That's it. But this is the only real limit.
Yeah, I want to say
Which is not
one clock, you have something like a clock gas limit, like a maximum amount of computation which can be done within one block. And this is so low, like any device out there can handle this. Like this is absolutely not a problem about the devices. This is by purpose that we set this in for reduce the growth of the blockchain, that it does not grow too fast and if you don't have DOS attacks, denial of service attacks. So basically, I would not say it's a problem of the single node, it's a part of the protocol which we put in that we cannot do much more than this for now.
So, wait, how's a protocol defend against DOS attacks? That didn't make sense.
So the DOS attack, basically every block has a block gas limit.
Uh-huh.
So who of you knows what gas is in Ethereum? Okay, good. So gas is basically a unit for how much computational storage can be done. And every block, currently it's about, I think 4.7 million. Maybe it's also nice to put this.
It has to start with 314.
It's
pi.
I think it's increased.
It has increased for Homestead. So before it was P million.
It was pi, right? Yeah.
Yeah,
And yeah, it was pi million. And right now the gas limit is 4.7 million.
How's that?
Tau million.
I'm sorry, I may not be able to see. How's that prevent a denial of service if there's a limited gas, if some malicious
So-
entity uses all the gas?
Yeah, but that's a good point, and they can.
Yeah,
And
so
that's-
it doesn't really prevent
They
it.
pay. They pay. It just means if what will happen, like the real point is first, here you see, for example, the gas limit can increase. If a block is full, like the gas spending was almost the amount, the next block has more, can take more. That's the first thing, like you see right now.
So it throttles.
Right now, someone is using it up. Every block is used up to capacity. You see the block gas limit increasing right now. And if they stop using it, it will go down. So you have a
It's a
dynamic-
throttle.
Hmm?
It's a throttle, a dynamic
There's
throttle
a dynamic
governing.
block gas limit, but it's not enough. Still, I completely agree with you. Someone, if he pays, someone calculated, I don't have the numbers in my head, but a couple of $1,000 per hour, if he pays this in gas, he could basically block the chain, but what would happen is, the gas price per transaction, which is shown here, would go up. And this just means you would pay more and more and more. And if you would say that my transaction is very important, I would put it in. And just increase it. Right now you see gas price just increased a bit. Someone is using it really. Every block is now used up to capacity. So really a nice example of someone who could maybe actually run a DOS attack.
That's great.
That's life. So yes, so the gas limit grows, the gas price will most likely increase, but only if the miners are also fast enough to adapt. Like the miners also need to say, I don't take in transactions like this. So there are a lot of dynamical processing needs to happen, but miners and also people selling transactions need to be aware of it, like to adjust their gas prices. Yeah?
What is this awesome website that you're on?
This is
Yeah, what is that?
stats.net. And
It's been out for a while.
it's just basically stats.net. Here, everyone can sign up his client there. So that's not a list of all clients on the network. It's just some
It's
clients.
opt-in.
It's it's optional, and they just report data about a network. If you want to see the whole network, there's also one site, which is nice. Things
From Seattle.
East Nodes.
Yeah, that's probably my house.
Ethereum Seattle, right?
Okay, that's all.
Actually, no, I haven't registered. I am running a node, but I didn't
Impress your
register.
friends by going from the page.
It's a laptop.
Someone wrote something like a crawler. He crawls the network for all the peers, and then disconnects to his old one and tries to find
It's
new
just a
ones.
node, yeah.
So just to find how many nodes are out there. Right now there are about 5,768 nodes, roughly. And you can see which clients they're using, which client versions, which operating systems they're using. You can see where they are, because he knows the IP of those clients.
I have a question. I was wondering, do pools count as one, or do they report that they're separate constituents?
Pools is only one, because there's only one node in the network.
Okay,
So
so
it depends.
there's actually node-wise there's probably much more because we know the
Probably much.
dwarf pool is like
This
40.
depends also on the pool. I'm not actually sure how the pool are implemented code, absolutely. And so I heard they are just giving their hashing power to them directly, like reporting blocks without being actually a node. So
Hashers.
this is only counting actual nodes. And I think block for mining pools is only one, but I could be wrong.
So there might be a number of nodes actually might be easily 10 times more or 100 times more. We don't
know. This is just a rough estimation of just a program which connects to nodes and then finds their peers and removes the old one, just goes through the whole network and try always to find new nodes, and then counts them here. So if I would now start a node, you would not see it here maybe for 24 hours until he finds mine. So it's a very rough estimation.
At 5,000 nodes, incremental nodes are exponentially less useful. 5,000 is plenty. So.
Yeah.
If this is how it works, then probably each node in the pool counts separately because if it goes from peer to peer, then your peers, if you have money in the pool, your peers, it's not related are not related to the fact that you're behind the pool.
Yeah.
So it's probably
more.
This might be the accurate number.
Yeah. So basically all those attacks, we have thought about them and they are handled in a like free market way. Like if you pay enough, yes, then you can attack, but the price will go up.
You can also send corrupt packets and a bunch of other nastiness, but yeah.
Okay, any other questions about Ethereum before we go to the way we fund ourselves? Because now very new things are possible. And I want to speak about something called a DAO, a Decentralized Autonomous Organization. And that's something we are pioneering, I would say.
Can you full screen the slides?
Yes.
Thank you.
So now I'm going back to Slock.it, because what is our business model? How actually do we make money? And I'll go to this a bit quick because I want to focus only on this part, but I give you the whole overview to see why we are doing this part. So basically, I will explain later what this is, but we will have a DAO, a Decentralized Autonomous Organization, where people can give Ether to it, the virtual currency of Ethereum, so they put money inside. With it, they receive a token. Slock token is a bad name, we actually named it BO token right now. So they get a token which basically says you are owner, which represents ownership and membership in this DAO. And they give a reward for the projects they fund. And they can vote on which projects they want to give money to. So they control their money. That's a very important part. So they don't give money directly to us, the service provider. The money is controlled inside the DAO smart contract and they stay in control of their money. So this DAO then basically hires us as a service provider to do certain tasks. So they give us money, we will produce those logs, so write the software, write the app and all the marketing and partnerships, all of this. And then we have programmed in those slogs that a certain fee of the transaction or a one-time deployment fee that's decided by the owner goes to the DAO. So basically the usage